All right, here we're going to evaluate the expression cos inverse of square root of 2 over 2. We can write this expression as arc cosine of square root of 2 over 2. Now, the most important thing for us to keep in mind when we're working with inverse functions is that the number that's playing the role of the input value, in this case the input into inverse cosine is square root of 2 over 2. The number that's playing the role of the input value can be understood as being an output value for the original cosine function. So what I can do is literally copy this input value in the given inverse cosine function, and I can use this input value as an output for the normal cosine function. And in order to figure out what cos inverse of square root of 2 is, we can instead try to solve this little equation and figure out what angle we need to use as an input for cosine to get the output square root of 2 over 2. Now, the only difference between the original inverse cosine expression and this pink cosine equation is that the inverse expression has exactly one answer. There's only one value that's equal to the given inverse inverse cosine expression. But for the cosine equation, it turns out there's infinitely many values theta that will make this equation true. But in order for cos inverse to be a function, we needed to restrict the range of the cosine function, and then we end up with a restricted range of our, we had to restrict the domain of our cosine function to define inverse cosine. It's a bit complicated. It's just explained in our online class notes. If I draw a unit circle, so I won't go through all of the explanation, but just remind us here that, trust me, that's a circle. Well, just remind us here that when we're working with inverse cosine, we're limited in the kinds of angles that we can set inverse cosine equal to. The angles have to be angles associated with the northern hemisphere along our circle. We only get to go around the circle a half of a time so that we don't repeat values. And on that northern hemisphere, we utilize all of the cosine values from +1 all the way to -1. We use all these cosine values on the northern hemisphere. And so the additional restriction we have on that angle theta is that it needs to be between 0. I'm sorry, I've got these backwards. It does have to be between 0 and pi. It's got to be in that northern hemisphere worth of angles. And so we need to find an angle with a cosine value of root 2 over 2 in that northern hemisphere. And we're familiar with how the 45-degree or pi over 4 angle takes us right into the middle of the quadrant, precisely where our cosine value is square root 2 over 2. And so that angle will answer this question. So to directly communicate the answer, we'll take the given expression, literally rewrite the given expression, and I'll use an equal sign to communicate that it equals to this angle pi over 4. And if you wanted to kind of explain why directly, you could say since the cosine of that angle, pi over 4, equals the desired input value for cos inverse, and that angle is in, oh gosh, I did it again, is in the desired range.